Calculate the magnitude of the normal force on a 15.2 kilogram block in the following circumstances. The block is resting on a level surface. So our free body diagram is going to look like this. Normal force going up, pushing back, and the mass times the gravity going down. And since it's resting, there's going to be no acceleration. So the sum of the forces in the y direction is equal to the mass times acceleration, which is 0. So this is 0. So the sum of forces in the y direction is N minus mg. So N is going to equal mg, which means that 15.2 times 9.8 is going to equal mg, which will equal our normal force, which turns out to be 149 newtons. The block is resting on a surface tilted up at a 35.8 degree angle to the horizontal. So this is our horizontal, the degrees is 35.8. Here's our block. Normal force is going against the surface, perpendicular to surface, pushing back. Our mg is going to be straight down. And we need to find the normal force. So this angle is actually equal to 35.8. And to find the sum of forces in the y direction, again, it's going to equal 0 because it's not moving. So N is equal to mg. But mg is straight down and N is going up at an angle. So how are we going to find that? We need to find the y component of the mg. So we're going to take mg cosine 35.8 adjacent over hypotenuse. And mg is the hypotenuse in this situation, so 149 for the mg times the cosine of 35.8 is going to equal 120. The block is resting on a floor of an elevator that is accelerating upward at 4.28 meters per second. So here's our block. Mg is going to be down. Normal force is up. And we have this acceleration here going up. So there is acceleration, so we can't make that 0 again. So we need to find the sum of forces in the y direction. It's going to be equal to the N minus the mg, and it gives us the acceleration of 4.28 meters per second. Squared. So we need to find the force, the sum of forces going up, which is going to be acceleration. I'll just write it out. Sum of forces equals mass times acceleration. And we know the mass and we know the acceleration, so we need to take the mass of 15.2 times that by the acceleration of 4.28. That's going to give us a force of 65.1 newtons. And then we have N minus 149. So to find our N, 149 is the mg. So to find our N, we need to add this over. So 65.1 plus 149 gives us a value of 214 newtons. The block is on a level surface and a force of 165 newtons is exerted on it at an angle of 35.8 degrees below the horizontal. So here's our block. Here's our horizontal. And there's a force being exerted on it, 35.8 degrees. And we know the force, which is 165 newtons. Our N will be going up again, and our mg will be going down. So the sum of forces in the y direction is equal to N minus mg minus this component here of the force, because it's only in the y direction. So to find that, we're going to take 165 for the hypotenuse of the force being applied times the sine of 35.8, opposite over hypotenuse. So 165 sine of 35.8 is equal to 96.52 newtons, and this is 149 newtons. And again, it's not moving, so this will equal 0. No acceleration, this equals 0. So we add these two values over to find our N, and we get 149 plus 96.52. Gives us a value of 245.52. 245.